make sure that we're saying the same thing. So when we talk about exponents and when we talk about powers, okay, so when I use the word power, I'm talking about this whole thing here. Okay, so for example, okay, let's say I had this. That whole thing is called power. Okay, the 2 is called the base. So the big number is called the base, and then the little number, that's your exponent. Okay, none of that should be new. Okay, so just some vocabulary. Okay, so a base with no exponents is understood to have an exponent of 1. Okay, so this is some of that invisible math. Okay, and someone asked a really great question on the quiz. They were just confirming, they're like, hey, when there's no index listed in a radical, do I assume it's 2? Yes. So if we're talking about exponents and we start talking about some of these exponent laws, if there's no exponent visible, it means that there is an exponent of 1, because anything to the exponent 1 is just itself. Okay, so that's why we don't write it in. Okay, so here's your example. 5 doesn't have an exponent, but we could write 5 to the exponent 1 if we needed an exponent to be there. Okay. Any power with a non-zero base, okay, and an exponent of 0. Okay, so this is your 0 exponent. We did this not too long ago on the 5 a day. Remember, there was like a whole bunch of stuff, and then it was in brackets, and then it was raised to the exponent 0. And some of you were like, not sure what to do with that one. Anything to the exponent 0 is 1. Okay, so this right here. Okay, so in your notes, like you could circle it or highlight it or write yourself a little note, just so you're kind of aware. So any number to the exponent 0 is equal to 1. Okay, any number at all. Even a group of numbers. Like, so say you had something like this. Say you had like a squared b to the 5th, c, I don't know, to the power 3. And all of that raised to the exponent 0, that's all just 1. Okay, you don't have to worry about anything inside the brackets if it has an exponent of 0, okay, on the outside. Right, and then don't forget, if you have a negative base, okay, don't forget your brackets. Okay, because, so I'm doing this one in red because it's important. So -6, okay, to the power of 3, okay, it is, okay, let me do this for a sec. Let me do their example. I'm not going to change things up here. There we go. All right, -6 to the power of 4, -6 to the power of 4. Okay, guys, I want you to take out your calculators because we've got to make sure that we can figure out with our calculators how to do different exponents other than just a little squared. Okay, I think for most of us, we'll be using the caret. Remember, the caret is that little triangle one. So if you have a calculator like mine, here's the caret, this one right here. Okay, so let's just clear my screen. Okay, so let's take a look at, I want you to put into your calculator exactly as you see it. I want you to do -6 caret 4. Oh, yeah. I think it might be charged up. At least it turns on. There you go. Just over half. Yeah. Okay, what'd you get? What's an answer? -6 caret 4. Whoops. Over. My caret did not caret. I did some weird stuff here. Oh, because I wrote on the board and it didn't like that. I'm going to just delete that mark. There we go. Caret 4. Okay, for some of you, it'll display the caret, and for others of you, it'll like give you the little exponent. Okay. Do you have a calculator prepped on? There you go. Okay. Okay, so you'll notice that we have a negative number, -1,296. Now, do your brackets and do your -6 inside the brackets, and then your caret and your 4. Okay, you'll notice, okay, that the number is the same, but one is positive, one is negative. Okay, so brackets are really important, And you need to be able to, sometimes I'll give you a question where the negative will be seated out in front, okay? And sometimes the negative will be inside the brackets. You need to know what that means and how they're different, okay? So sometimes when you enter stuff, okay, you know what, like you know in your head what you're supposed to do, but then you enter it wrong into your calculator. And so it's a calculator error. So I want to make sure that we don't have any calculator errors, okay? So these two, okay, do not equal each other. They're very different. So this one tells your calculator to take the fourth root, right? So do 6 to the exponent 4, and then multiply it by a negative sign. This one is telling you, okay, this one here is telling you to go -6 times -6. Like take the negative with you, okay? So that one ended up being a positive number, okay? And this one ended up being this, negative, okay, times 6 times 6 times 6. That's what it did here. Okay, so they're very different, and you will get a question that has you figure out what the difference is. Okay, so for this, go ahead. Okay, underline the base and circle the exponent of each of the following powers. Okay, pull out your notes. Go ahead and do that. Okay, let's make sure that we know which one is the base and which one is the exponent. Okay, easy peasy, hopefully. Okay, underline the base, 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 base. Okay, circle the exponent. Exponent is 3, the exponent is 7, the exponent is 2. Here, the exponent is y. Like, it's okay if it's a variable, okay? This one, the base, the whole base is -10. Right. Okay, I believe you guys have done exponent laws in the past, okay? This should not be new, okay? But, like, give me a little wave if you're like, this is new for me, okay? But you guys learned last year, or even grade 8 for sure. I'm trying to think if we did it in grade 7. Okay, I think we even did it in grade 7 because I taught grade 7. Okay, so you guys have seen this for a little while. Okay, we have something called the product law. The product law says that when you have the same base with exponents and you're multiplying them, that you can add your exponents. Right? So this is what it's doing. It's like our base is A, and it's saying that we can add our exponents. Okay, let's do like a real example. So let's say we had x squared times x to the power 5. Okay, the bases are the same. The bases are x. Okay, and the x's are being multiplied. That's our product law. Okay, they have to be multiplied. So that's what my dot is, right? My dot is multiplication, and it says I can add my exponents. Okay, the quotient law. Quotient means divide. Okay, that means that, okay, when I have the same base and I'm dividing, I subtract my exponents. Okay, we can write it like this, or we can also write it like, let me get my A in here. We can also write it like this, A to the M over A to the N. Okay, so this is the same thing. This is a division sign. This bar is just a division sign. Okay, and what it means is we can then, okay, subtract our exponents. So for example, if I had W to the 7 and I had W to the 4, okay, and I'm dividing, okay, so the same base, my W's are the same, I end up with, subtract my exponents, 7 subtract 4 is 3. Okay, and you guys also learned power of a power. So power of a power means you have an exponent and then you have some brackets, and then that is like to another exponent. Okay, when we have power of a power, what we do is we multiply the exponents together. You remembering or? Okay, I'm just making sure, like we need some visual contact here. Yes, we know, or like it's new? Yeah? Okay. So here we're doing M times N. Okay, so again, for my example, let's say I had X to the power of 3 Okay, and then I'm going to raise all of that to the power 4, right, to the exponent 4. So that means that, okay, guys, if I were to write this out, I just want to show you, like, kind of like prove that why this is the case. Okay, when I have an exponent, that just tells me how many times I'm multiplying that by itself, right? And so this to the power 4 says whatever's in the brackets, I'm writing it out 4 times. Okay, so it's like this. You know, I wrote it out 4 times, right? And then we know if we have the same base, we can add the exponents, 3 plus 3 plus 3 plus 3. Okay, that gives us 12. Or we could just multiply these, right? Because mathematicians like shortcuts. Okay, that's why they're the same. Okay, this I was just showing you. I don't want you to write this out. I just want you to be able to take these, right, multiply them together to get x to the 12. Okay, but this is the why does it work? Why is it that case? Okay, this one might be, I'm not going to say it's new, okay, but it'll be like, oh, okay, that makes sense. So what happens is power of a product law. So this just means that when you have two things that are being multiplied together, right, these are two different bases, an A and a B, they're being multiplied together in my brackets, and then I'm raising everything to the exponent m. Okay, that means that I can take that m, okay, and I can multiply it by each of the exponents inside the bracket. What exponent does A have? 1, right? Because it doesn't have an exponent, so we know that we could write the exponent 1 for both of these. So this is the same as A to the m, B to the m. Okay, let's just do it. Let's do an example. Let's say we had x, okay, x squared y, and okay, all to the exponent 3. Okay, so what it's saying is I'm going to apply this 3, okay, to the x squared because it's a power of a power. That becomes x to the power of 6. And then I'm going to multiply the 3 by the exponent of the y, which is 1. So we have y to the power of 3. Okay, you guys have seen that before? You've done that? Okay. Right. And then the last one, so the same thing happens here, whether you have a multiplication or whether you have a division. Okay, this just means that you have a to the m and dividing by b to the m. Each of them get the exponent that we're looking at. Okay, so for this example, let's say we had w to the power of 3 over x, just over x. Okay, and then okay, I did it to the exponent 5. Okay, that just means that each of them would get the 5 because this is a power of a power. It would be w to the 15 over x to the 5. So we're just multiplying 3 times 5 to 15, 1 times 5 to give me the 5. Okay, so the 5 gets to go for each. Okay, so exponent laws are used to simplify expressions. So when you see the word simplify, okay, we're just going to apply the exponent laws, okay, because we're trying to just get rid of brackets and all that stuff. Okay, so let's practice a couple, and then we'll get you guys going on some of these. Okay, we will do. You know what? I think you guys could do this. Why don't we? Okay, just give me. Okay, do these in your notes, and let me get set up for the next set. Okay, so see if you can write these ones out, and then we're doing some great board work up here. I thought I would record some of this as well. Okay, if 6 does not go into 14 very well, you might be just having to leave it as a fraction, okay, but in simplified forms. Yep, so simplify your fraction. It's okay if you have a fraction. Okay. So what number, how can you simplify 6 over 14? What number goes into both 6 and into 14? Yeah. Okay. So Is your group in agreement? I'm coming through, pardon me. Thank you. Okay, so what have you got? Okay.
Question written though.
Okay. Yeah. Okay, so if you don't, okay, forget the numbers first and then just do the same base and we're dividing. That one you can do. Yeah, because you have 4 minus 1. Yeah, because you have negative 3 and then you're subtracting another 2. Okay, so how can we simplify 6 over 14? Yeah, if you divide both of them by 2. Yeah. Yeah, so then you could just write 3 over 7 in front of that.
Oh, I see now.
Yeah. 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 Okay, how are you ladies doing? Okay, so you got the simplified fraction. Okay, how about same base and now we're dividing.
4 minus 1.
Yep.
And then negative 3 minus 2. So 5.
Awesome. Cool. Okay. All right, coming through. Okay, good job helping each other on that. So we decided it was going to be 3 over 7 because we divided top and bottom by 2. And then when we subtracted 4 minus 1, gave us x to the power 3. And then negative 3 minus 2 gave us y to the negative 5. Okay. Let's do a few more. Okay, guys, turn over to the next page and look at example number 3, the one in the middle. Okay, look at the one right in the middle, example number 3. Okay, give that one a go. Okay, give it a try. Now I'm going to give you a hint as you're getting started. Okay, so write everything out. Okay, my hint is, okay, when we do BEDMAS says that we have to, okay, it says brackets, right? But the brackets are all simplified. So the next step is actually the exponent, and then you can do all of your rest of your exponent laws and multiply. Okay, so I want you guys to take a look and do this exponent here, the last one with the squared. Do that first, and then you can do multiple bases. Okay, so let's see where we're going with that one. Okay, so if we do a little bit at a time, we have negative 2 times negative 3 gives us 6. Okay, we're multiplying the p's, and so we add the exponents. 3 plus 1 gives us 4. Okay, now we're doing the q's. 1 plus 2 gives us 3. Okay, so those are the first two, and then we still have this 16q to the exponent 12. Okay, so 6 times 16. Okay. 96, okay? So we have 96. What's our p? Okay, there's no p to multiply it with, so p just stays p to the power 4, right? Did you guys have that? P to the power 4, yeah. Okay, and then q. We're multiplying the q's, we add the exponents. Okay, so you should have q to the power 15. Awesome. Okay, good, good, good. All right. Hey guys, take a look at example 2. This will be our last one. Look at example 2. Okay, example 2 says, example 2 wants you to do some substitution. So what I want you to do is, before you substitute, I want you to simplify this expression. Okay, so give me all the exponent laws that you can. Right, so we're doing power of power. I want you to simplify the expression first. We've got a division going on. Okay, so I see a couple things. We're doing power of power, then we're doing the divide, and then at the very end, then you're going to do a substitution. Okay, so break it up into parts. Ready? Let's check in. So if we simplify this first, so we have a to the power 6, b to the power 9. Okay, just like I just had to rewrite it. Okay, so if we had a to the power of 1, because 6 minus 5 is 1. B to the power of 1, because 9 minus 8 is 1. And if we squared that, we ended up with a squared, b squared. Now we can substitute. So when you substitute, you always put brackets around what you're substituting. Okay, so we're putting a -3 in for a, so -3 goes into brackets and it gets squared. We're putting a 2 in for the b, put it into brackets, it gets squared. So we end up with 9 times 4, which is 36. Okay, how'd we do? Okay, yeah, 9 times 4, 36, looks good. Okay, update your notes.